Dun, 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 a grain of basalt settling through water. Everybody needs to solve this problem, right? So here's our basalt grain, right? Gravity is, of course, pulling down on this, right? And then we've got the Stokes force as it moves down, right? The Stokes force is pulling up. And in this case, since it's in water, there's also a buoyant force, right? Okay, so ultimately we're going to say that the Stokes force up plus the buoyant force up turns into equals gravity, right? And then let's just substitute here, right? So the Stokes force is 6 pi viscosity RV, right? And the buoyant force is the density of the fluid times the volume of that thing, right? Times gravity, right? And then that equals, for the mass, you'd have the density of the object, or in this case, the basalt, right? Times the volume of that little grain times G. Okay. Now, I like to rearrange it this way and put these guys together, write it this way, 6 pi equals, and then I can just do a little subtracting here, right? I can go the density of the basalt minus the density of the fluid, in this case the water, the button. Okay, here we go. Right? And then that equals, what is it, density basalt minus the density of the fluid, in this case it's the water, right? And then our volume is 4/3, r to the third, and then g is still g, right? Okay, yeah, this is good. Okay, and then notice that I can, what are we trying to do? What speed? Oh, we're trying to find the velocity. Okay, so good. Notice that pi goes the way of the bison. Notice that one of the r's goes away, and that's squared. So we end up with 6. Wow, it all canceled. V equals of the basalt minus density of the water times 4/3 pi r squared times g, and then we're trying to solve for the v here, right? Okay, so ultimately I want to divide this side by 6 times that, right? And that would give me v. Okay, now notice that this is going to become like something like 2/9, right? Okay, but anyway, I'm just going to plug it in. I don't feel like simplifying anymore, so I go parentheses. Basalt is 2920 minus water, right? So it's settling in water. You'll have the density of water, which is 1,000. So 2920 minus 1,000, right? Times 4 divided by 3 times the radius, right? So 2.2 times 10 to the minus, so e minus 6 squared. Don't forget to square the radius, right? Times g times 9.81 divided by parentheses 6 times, what speed does it settle in the water? I do believe I was telling you guys to use 1.002 times 10 to the minus 3 Pascal seconds for the viscosity of water. So let's plug that in. Let's hope that we get the right answer. Okay, so 1.002 e minus 3, right parenthesis. Let's see if I've got it. Enter. I sure hope. Okay. Oh yeah, you know what? I put in the 2.2 as the radius, but it's got to be I got to put in that's the diameter. Okay, so second entry. Let's go back up here. It's really 1.1. Here we go. Hold on. 1.1. Please work. Oh yeah, there we go. Okay, so the velocity is 5.05 times 10 to the minus 6th meters per second. There we go. So this is what I put for the buoyancy. This guy is 2920. This guy's 1,000. This is 1.1 times 10 to the minus 6th. This guy is 9.81. This guy is 1.002. That should work. Yeah. All right. Yeah, don't mess up the diameter with the radius like I did.